why don't I just show you a very quick demo of the product so that you can actually see how we do these things. Now, many people say, well, I get some of these from my APM tools. They also rely on OpenTelemetry. We don't look for the monitoring data. Most importantly, we apply a different layer of intelligence on the tracing data, and we focus on how your architecture is actually evolving. That notion of identifying architectural drift doesn't exist with APM tools. Okay, so let me just show you, and we can take it from there. So what you see here in front of you is a distributed system where each bubble represents a service. We see that there are a bunch of Java services, and there is one Node.js service. The sizes of the bubbles represent sort of the centrality of these services within this environment or system, which means that the size relates to the number of flows that go through that service. Okay, and the color of these bubbles represent the degree of resource exclusivity, meaning if it's green, it talks to database tables uniquely. So these database tables are accessed uniquely by that service, whereas if you have a red bubble, that means that it's accessing resources, such as database tables, with other services as well, which may introduce an issue. So that would be something that you may want to look into from an architectural perspective. The dotted lines represent calls between these services, and I can go into a specific service and get more information, like the entry points and the resources. In this case, 8 resources are non-exclusive, and all of them are database tables. We can then go further and actually look at the resources report where we map the different resources. Okay, and these are the type of resources in the system, be it Kafka, SQL calls, Redis, MongoDB, and others. If I focus, for example, on database tables, I can see for each database table which services are accessing it, and I see that some have multiple services. So, for example, this database table, the payment info table, is being accessed by 2 services. And indeed, I see the ONS service and the ONS order service, and we know that the ONS service is red. So indeed, it is accessing the same database tables with other services. What I also see here is that this database table is being accessed by 3 services, and again, the ONS service is there. And this one is also being accessed by ONS, and of course you can look at it both from a database perspective or from a service perspective, which really makes it easier to understand. So here I have the list of services and the different database tables that they access. Now, the fact that you have multiple services accessing the same database table is indeed an architectural issue that you may want to pay attention to. And the system automatically lists these different architectural issues as to-dos that you may want to address. So beyond that, what the system does, it not only visualizes at a high level the system, it actually goes much deeper and draws the different flows in the system. And we see that there are 32 flows in this system, and it generates the sequence diagrams for these flows. So, for example, I just clicked on a certain flow, and I can actually see the different API calls and the exact kind of a sequence of this flow. And I see the API call calling the ONS shipping service. It's calling the participant service, and then it's calling the ONS service back and forth. These diagrams are all exportable and are generated in real time, based on what the system is observing with the OpenTelemetry. Not only that, let me move to a different system, which has a bunch of Go services. In fact, this is the back end of the vFunction system itself, and we kind of generated specifically some architectural issues to show how the system identifies them. So, for example, we see that there are 293 flows in this system, and I want to specifically focus on the overly complex flows that may be impacting the resiliency of the system. For example, circular dependencies. Okay, and so here, I see that the system identifies 7 flows out of these 293 flows that represent circular dependencies, and if I click on it, I can actually see them. So in this flow, I see that it introduces this loop of 431 times that the organization is calling the measurement and goes back and forth again. That actually is something that we see in the slowness of the system. This is where architectural observability essentially complements your APM tools. As you see the performance issue there, you may even see an outage. But through the architectural observability, you can actually go down to the root cause. And in this case, it's a circular dependency. The system allows you also to filter multi-hop flows, which are flows that have too many hops in them. And again, here I have 9 out of these 32, and it shows me these flows that indeed have maybe too many hops, and you may want to consider simplifying them. Another thing that I want to show you here before I move to the actual drift measurement is the architectural rules. So we have the architecture. That is in the system. The system allows us to actually add specific architectural rules. So I can decide, for example, that I want to alert when a certain service and I have here the list of different services. Or I can tag multiple services into a group of services. Maybe the core services should be calling the IDP service, and I can even set a priority for this. Now, this is one type of architectural rule. We have different types of rules, so calling services, accessing resources, and so forth. I can actually run and execute a dry run where the system validates these rules versus the current architecture to check whether they are indeed valid. And we see that rules number 1, 3, and 4 are indeed green, so there's no violation there, whereas for rule number 2, the consumer calling any service, there are 5 to-dos, meaning the system actually tells me what I need to fix in order to adhere to this rule and not violate it. Okay, so these are some of the basic capabilities of the system, which brings me to the actual setting of the architectural observability. So this is something that is unique to architectural observability and does not exist in any APM tool. The notion of having a base architecture and then measuring how the architecture is drifting versus the base measurement is the core vFunction capability. So here are the things that the system will alert us on. For example, when there's a new domain or service, when there's a new dependency, where a resource exclusivity changes. That means that a database table now is being accessed by multiple services, which wasn't the case before. When a new circular flow is identified, where multi-hop flows are identified. When services maybe ought to be merged. So that is an example of services that rely on the same resources and have similar API calls. The system will surface those and recommend, maybe merging them in order to simplify the system. Obviously, it will simplify deployment, it will improve performance. It essentially helps you combat the microservices sprawl problem and remove duplication. When new flows are added, when flows are removed, when a rule is violated, this relates to the rules that I just showed you, when there's a violation of those rules. You may get an alert when there's a recommended refactoring. Something that we've added recently that customers have asked for is to get alerts when non-encrypted HTTP calls are identified, or when a new resource suddenly is identified, meaning alert when a new resource is detected in one of the flows of the system. So the system will generate alerts, whether email or Slack, or to our generic dashboard. It allows us to set this measurement as a baseline and also trigger when we want to measure it or collect the data because, as opposed to APM tools, we don't have to collect data from the open telemetry all the time. We can just collect data each time you release, so you can actually measure the architecture and identify how it is drifted. We don't have to observe the system continuously. We also don't collect the amount of data that APM tools do because we don't look for logging. And even the traces, we analyze that in real time, and we don't keep all the tracing data. We only keep the analysis and the outcome, which we've just shown you. You can tie the collection to whenever you deploy with a CI/CD trigger, and then you would collect the telemetry information for a certain period of time. To summarize, I hope you get sort of a basic understanding of how you can get additional value from your open telemetry deployment beyond APM data that focuses on performance and outages. APM tools are important. We're not replacing APM tools, but we complement them with deep understanding of the architecture, how it's drifting over time, and allowing you to control that architecture, so you don't get to the microservices sprawl problem that you lose control and eventually your system slows down. Resiliency is impacted and scalability drops. Thank you.